So we want to represent the function 3x squared sine of 2x as a Maclaurin series, and then we'll write out the first few coefficients. We are going to think of something we already know. We know the Maclaurin series for sine x, so we'll be able to utilize that. And so 3x squared sine 2x is going to be 3x squared, sum, and going from 0 to infinity. We can use our sign, but we need to, instead of having x, put in 2x. So we have negative 1 to the n, and then here we have 2x to the 2n plus 1 over 2n plus 1 factorial. Now we can rewrite this a little bit. We can move this x squared inside and combine it. So we could put it, that was a plus 1, didn't show up. So we can put an x squared in here, and then we could combine these. So let's go ahead and express this. I'm going to move everything inside so we don't lose track of it. So we have negative 1 to the n times 3 times 2 to the 2n plus 1 times x to the 2n plus 3, because we can combine this adding these exponents, and then that's all over 2n plus 1 factorial. So there we've got our function expressed as a Maclaurin series, and then we are going to find some coefficients here. And when we do that, first of all we put in 0. And we get, if we put in 0, that's 3 times 2 is 6, and this is actually going to be an x to the third over 1 factorial. So our first term is going to be 6x to the third. So actually this one's 0, this one's 0, this one's 0, and this one is 6. So let's find another two of them, because we've got all these zeros, and we're going to have another one here. When we put in a 1, we get a negative, and then we have 3 here. When we put a 1 here, we have 2 to the third, so that's going to end up being 24. But when we put a 1 in here, this is over 3 factorial, so that's 24 divided by 6, so that's going to be 4, and then x to the, we put a 1 in here, that's going to be x to the fifth. So this coefficient's also 0, and then this one is negative 4.